In this lesson, we're going to be using different models to add two fractions that have related denominators, which means they'll have denominators that can be multiplied to end up being common. So get your whiteboards out, get ready to participate and draw along with the problems. And if you have any questions, you can always stop the video, come up, ask me for some clarification, and we can help you move through the lesson. As I said, you have your whiteboards out, get ready, and work through the 5 or 6 slides. Okay, boys and girls, I went ahead and drew the tape diagram ahead of time. So what I suggest you do is pause the video right now, go ahead, draw what I have written here as far as the tape diagram and the equation that's shown in the tape diagram. Once you have all of this drawn on your whiteboard, restart the video and we'll solve this problem together. All right, I'm assuming that you have everything drawn. And let's look at our tape diagram right here. We have 3/16 of water in the morning. We have 5/16 in the afternoon. And we have 3/16 in the evening. That's why we have 3/16 here and 3/16. What we're going to do is we're going to add these together. We have a common denominator of 16ths, so we don't have to worry about decomposing anything. So it's simply a matter of adding 3 parts with 5 parts with 3 parts and ending up with 3 plus 5 is 8. 8 plus 3 is 11/16. So we end up with 11/16. Now that still doesn't tell us what our whole missing part is, but we do now know that this part is 11/16. So we're going to take 11/16, and I know that if I break this whole bottle of 1 into 16ths, then I'm going to end up with 16/16 equals 1 bottle of water. So now it's a matter simply of subtracting. We're working in 16ths as our parts, so we're going to keep that. And we're going to subtract 11 parts of from the 16 here, and we end up with 5/16 as our answer. So she had, at the end of the day, she had 5/16. All right, in this problem, we're going to be adding two fractions that have related denominators using a tape diagram. But let's look first what I have here. This is a banana, and this is an orange. If I tried to add these two together, what would that equal? Well, it's not 2 oranges, because one's in a banana, and it's not 2 bananas. But what do bananas and oranges have in common? They're 2 pieces of fruit. So I would have 2 fruit is what I would have if I were to add these two together. So in this case, we're going to look at our next problem. It's 1/3 plus 1/6 equals. Well, again, this would be something like bananas and oranges, but what do they have in common? Well, we could look at this as they both have this in common right here, that this 3 can become a 6. So let's do this with a tape diagram first and show this. So the first thing I'm going to do is I'm going to draw out my, I'm going to make this, I'm going to make thirds. So here are my thirds, right? And I know that this is 1/3. Well, then what I can do is I can look at this and I want to make my 6th. Well, if I want to make my sixth, this is 1/6. So I know that if I want to change this third into 6, I know that 1/3 now would equal 2/6. So I can add this up by doing this now. I can come along and I can create my new problem, which would be 2/6 plus 1/6 equals 3/6. I also can look at 3/6 now. I can go like this. And if I look at this 3/6 would equal 1/2. All right, our next problem, we're going to be add fractions with related denominators using a tape diagram again. If we look at this one again, as we look back to the previous problem with bananas and oranges, we know that both of what do these two have in common when I look at their denominators. I'm going to look at 3, then I can turn that 3 into a 12, and we're going to show that using a tape diagram right now. So I'm going to first I'm going to draw 2/3 in a tape diagram. Now if I look at this, what I did was I drew a 2/3 tape diagram, that this all equals 1, and the 1 has been divided into 3 parts, and this would be 2 of those 3 parts. The next thing that I want to do is I would like to draw, I can use the same tape diagram if I change colors, so I want to take, and I want to draw this into 12. So I know that in order to do this, I would have to go and we could count this just to confirm that we have 12. We'll count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now I know I have 12, but I want to mark out 3 of those 12s just to show that this number down here, we'll mark it in here. And this would be 3/12. Well, I'm going to keep the 3/12. 3/12 plus, now I have to know how many 12ths would be in 2/3. So let's count. We know we're going to go from here. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to be adding up 8/12. And at this point, I know that I add my numerators, and because we're working 12ths, just like we were working in fruit, we're going to keep the 12ths. So we have 12, and 3 plus 8 is 11. So my answer in this case would be 11/12, or circle there. Alright, boys and girls, I want you to take a look. In this problem, we're going to be using a number line to solve this addition problem where we have related denominators. We have a denominator of 6 and we have a denominator of 12, and they are related. We know that we can get this 6 into a 12. So if we look at our number line right now, I know that 1/6 is less than a half, and I know that 3/12 is less than a half. So my number line can have an anchor point of 0 at one end, and 1 at the other end. And then I went ahead and I divided my number line into 6. 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6. After that, I divided it into 12ths. Again, 1 12, 2 12, 3 12, 4 12, 5 12, 6 12, 7 12, 8 12, and so on. All right. So what we're going to do is we're going to look at adding this up here. And I kind of gave my answer out, but that's all right. What we're going to see now is we're going to start with 6. We're going to start at 1 6. So we're going to add 1 6, and we're going to take a big jump, and here's our 1 6. The next thing is we want to go 3 12ths. So here's, we'll do this with the blue. Here's 1 12th, 2 12ths, 3 12ths. So this would be our plus 3 12ths. And what did we land on? We landed on 5 12ths is our answer. All right. All right, we're on to our problem 4, and in this one we're going to add this without using a model. So without using a model, what we're going to look at is 2/5 plus 3/10. And again, we're going to look at what do these two have in common. Well, we know that they both have 10 in common, that I can turn this denominator of 5 into a denominator of 10 by multiplying it by 2. So again, we remember always have to do what we do with the denominator, we have to do with the numerator. So I'm going to multiply this by 2. So I'm going to go 2 over 2 times 2 over 5, and what I end up with is 4. 2 times 2 is 4, and I know that 2 times 5 is 10. Now, look at that. I have matching denominators. So now I can simply add 3 and 3/10, and this equals 4 plus 3 is 7 parts, and our denominator stays the same. So that's our answer, is 7/10. All right. In this lesson, you saw several different ways of using tape diagrams, number lines, and adding without using a model by multiplying the denominator numerator. The idea is that you can use any one of these tools to add fractions that have related denominators. So go ahead, move on to the problem set, which you'll find in Class Kick. If you have any questions, don't hesitate to ask.